if you don't have but
well, the solution is a solution for the last question. Do you mean?
Yeah.
Yes, we have. I don't have. Well, at this stage, I think we were, as I say, we were considering the method. Okay, and where the numbers. The answer to that question is that whether you can confidently say that the path difference can be determined by measure the intensity of the signal. Do you remember? Do you mean the answer to that question?
That if like it's not like really easy to be solved, then I don't want to put too much energy on it. It's just too tired. Because I couldn't understand what you are working on, like last lesson.
Oh, yes,
yeah.
see, there are two methods. So basically, when you solve the question, there are two types of method. One is analytical, another is a graphical. You can see. Now, if I change a method, perhaps you can follow me. So but that is essential part of your preparation, the interference. The formula is slightly different from your ATA examination. I just go to the whiteboard. I remember. I just go. We can discuss a little bit about that. It's basically say that when the two signal meet, right? It become detected. However, this signal is not unlike ordinary signal, so the signal can be read. Do you remember that's equal to? I remember equal to PQ. The cosine 2 pi divided by lambda multiply L. Do you remember the formula, right? So last time, so basically it's periodic function. Do you agree?
Yeah.
The periodic function means that they have the minimum, they have the maximum, like a trigonometry. It's cosine function, isn't it? Well, it's certainly they have answer, but you have to understand what is the question, what is it trying to ask. If you draw this diagram, you will see the oscillation. You see, it will just start from zero. It starts from zero. That will be just cosine, isn't it? Like this, can you see? So what happens that this curve represent the signal. This is the signal S, right? So the intensity is vary. So if you just put the light bulb here, so sometimes it's a dim and sometimes very bright. Can you see that?
Yeah.
So you will see the intensity change like this. Can you see that? So their question is, how can we work out this L, the path difference with confidence that there is a maximum difference between these two signals? Well, the last time I remember I give you, but I didn't record that part. Last time I give you an analytical formula by using first derivative where I try to find the delta L as function as this. We use I here. I think we use I here, which is a proportion to I. Can you see? Do you remember? And in front of that, we got the cosine something. This is analytical based, all right? But if you really do understand that you can use this graph, you can obtain this from this graph, because you can see can we start from difference equal to zero? As the difference increase, the path difference increase, we can see intensity change. Can you see?
Yeah.
So in other words, by measure the intensity here, we can definitely work out the L. Do you agree? However, if the L is larger than this one, I change the color. If the L is larger than this one, we still can measure intensity. Do you agree?
Yeah.
But this red colored one, from this information, we can hardly determine the path difference. In other words, we have no confidence, because if you measure something, if the path difference is larger than this maximum, okay? Actually, this is what they are looking for. If the L path difference is larger than this one, then we can hardly say, we can hardly use this intensity to tell the difference. Because this value is the same as this one. Can you see?
Yeah.
This value is same as this one. So the answer to that question is that at maximum, we can only depend on this maximum and minimum interval to work out the delta L. Beyond this delta L, we cannot make a conclusion. That is answer.
So you're only finding the delta L. Is that a constant or a variable? Delta L.
Constant is just pick up. Basically, they are looking for if it's the change in L. Because if the change in L would induce intensity.
Yeah, then why wouldn't just derive that formula and then just...
Well, what I did last time, if you have static calculus, that is a formula. So if L, dL, di, that is a formula. The formula I give you is this formula. And you say, well, you have never seen this formula. This is a calculus formula. You see, this first, have you seen this formula? This is a calculus formula. When you study calculus, this is for how do we use the formula. You have two variables. If you want to estimate one from another, you have found the derivative. That's why we try to find the derivative.
I'm thinking my logic is the yellow line, the function here.
Yeah,
It's this one, right?
Yeah.
And then you just find
that's right.
Find the first derivative of that one.
Yes, that's right. So basically, this is function. So last time, well, I use, as I say, that's what we call analytical method, okay? That's called analytic form. So that's why I say, well, ultimately, you have to use the maximum change in intensity to determine this delta L, how far you can go.
Is it correct if I do this and then find the L?
Oh no, not that. No. So basically, I think what I can do. Can we just pick up this as example, all right? So what you can do, you can assume that the original difference, the L is this one, so the intensity is minimum, okay? And between this one and this one, we can confidently say we can actually use the intensity to determine the path difference. Can you see? Because once we know the intensity, we can pinpoint this L. Can you see? Once we know the intensity, we can pinpoint this L value. Can you follow? This is graphical method. Yeah, this is I, this is L. Can you see? So we can do so until we reach to the maximum. Okay, this is the minimum, this is the maximum. In this domain, we can always find this one-to-one correspondent. Can you see?
Yeah.
So in other words, as long as the intensity vary from the minimum in this region, we can pick up the path difference with confidence. So that's what I'm looking for. So in terms of wavelengths, if you go to this background, so we know that when we see this one, what is the peak to peak distance from this formula? What is lambda? Did you say lambda?
Yeah.
Yes, that's correct. So that's lambda. So in other words, if you go back here, so what with the confidence, what is delta L is just half lambda. That is answer.
Yeah.
Okay. Is that I'm looking for? You can if you found this formula is a strange little bit strange, then you can pick up graphical one. Yeah. That's right. I mean, there's no point to solve every question. You see, if you are prepared for this exam, no matter how many questions you have solved, you still have prepared psychologically. You have prepared that one or two questions appear very strange or even have no idea. You understand? This is you have to just like any entrance examination. You can't just say I can solve every question now. You can't.
Yeah. I still don't get the mass expression. You just skip it. I don't want to pay too much attention on it.
Well, then
Yeah.
it's up to you. So basically, if you this is part of this is very important a part of the. So do you remember the double? Can we just go to? Can we use a double Smith experiment to explain to you? All right. This is again very basic. This is very essential part of this test. For
No,
example, you have two
understand
holes here. You know, yeah. Let me finish.
I understand the interference part. It just this mathematical expression.
Oh,
Yeah.
and in mathematics, that we invented this one to estimate the difference. Can you see? So if you have the function, right, and if we want to work out the delta, if we want to work out this the delta function, the delta y, and we over the delta x, okay.
Yeah.
So what we do, we just use this is the first derivative. Can you see? That's the tan, that is equal to tan alpha. Do you agree? This is not strange at all, actually. Can you see that? So once we know the slope of this curve here, then we can estimate delta y as the product of the first derivative multiplied with delta x. This is a basic formula in calculus. Can you compare with it? Can you compare this formula here? This exactly that is exactly the.
So you have this?
Sorry.
The angle?
Yeah. Yes. Slope. Yeah.
What's
well, when you start calculating, what did the teacher tell you? Yeah, this is called a slope or called a gradient. This is called a gradient. This is first derivative. No, delta. Sorry, delta. Change is called a gradient. So what you? Yeah, of course you have studied it. You just because we use L and I. You normally use Y and X.
How does it change the derivative?
Oh, that's it. That's exactly what I'm looking for. The derivative.
What's tan alpha?
Tan alpha is a derivative. That's a derivative. Yes, approximately. In this, can you see? Approximately, this is a right angle triangle.
Okay.
Can you see? So therefore, by definition, tan alpha is equal to delta y over delta x.
So confusing. but it's a curve though. The straight line is tangent to some point.
No. It's approximation. So that when I derive this formula, I'm trying to estimate. This is analytical method. If you want, even this tangent is that slope, and it is very close to that. And this again, this is approximately correct. Okay. So there, if this slope is a curve, that's right. So that would be the tangent alpha. All right. Of course, if you go too far, and this triangle, this formula is not correct anymore. This is delta x. Can you see? Delta y will be here. Can you see? Delta y will be here. However, if the delta x is small, and we can certainly use this triangle, right angle triangle. Does that make sense now?
A bit.
Yeah. Well, it doesn't matter. It's depending on how did you learn calculus. If you study this, when you start calculus from this approximation, so this is approximately right.
Okay.
Obviously when x gets very small, it became very accurate. That is why.
Yeah.
Another issue is that another thing I think I remember is that when you see this formula, you say never say why. It's very strange. You should be able to derive this formula.
Yeah. I learned trig identity at school, and there's like 4 sets of rules, but only 3 of them are on the formula sheets. This is the 4th one.
Yes.
Yeah, I learned it before.
You want to know how to derive the formula?
Yeah, I have
a little bit of math here. So this is a sine and the cosine, but this is half angle now. So this is alpha plus beta. Okay, and this is cos, I remember cosine alpha take beta. That's why we got this formula for in order to work out the solution. Do you want to try how to solve this question to prove this identity? I tell you how to start. Okay, if you know the sum actions. If you have, say, you have the sine A plus B, the two angle, and you write down the two formula, then you can solve that by yourself. A minus B. Can you write the two basic formula first?
Can I cheat?
You can just copy from your formula.
Yeah.
That's the basic one. Yeah.
Wait.
Sine A, yes. Cosine B, yes. Okay. How about the difference? Okay, I give you a hint. If you just add them up, what can we obtain?
Those two cancels out.
That's right, yes. Yeah.
And then it becomes
That's right. Okay, can you find other way? Can you any way to? So we're trying to prove this formula here. Can you see? We are trying to prove this the sum. So we got the sum formula. Oh, sorry. We try and prove that can we say we got the form is correct now? So when you prove the mathematics, can you see the form? This is two sine. Can you see cosine? Can you see? And this side is a sine and a sine. So we got the form is correct now. Can you see? So the next one is just do substitution. So when you study mathematics, solve the math, substitution is very important. Can we do some substitution to solve this puzzle? Just one more step. You can solve this. You can prove this useful trigonometry equation. What can we do? So we are wondering, are these two formula are identical?
what can you substitute?
Well, that's why you have, yeah, probably. So I will give you a hint. Can you see the only difference is that if I just pick up from the first one, this is alpha, this is A plus B. That is difference. What can we do?
Let alpha equals A plus B.
Yes, go on,
Okay.
try it. You see what will happen. Yeah. So what is alpha? Can we in terms of A plus B? Oh, sorry. What is A alpha plus beta in terms of A plus B?
Alpha plus beta.
That's right. That's right. So in this way, both A and AB and A plus B can be represented by different variable, two different variable. Here's A, can you see? What is formula for A? One more step. Yes. I think it's a very useful formula. This method is very useful for you, all right?
Okay.
Okay. So let's go to the back to the paper. We didn't finish. By the way, when is your examination day? This month?
Yeah, next month.
Next month. Oh,
It's 2 weeks away.
2 weeks. Oh, okay.
Yeah.
You can give me any idea how do we use this time properly, all right?
Yeah,
And
I think it's just finish the paper and
I think after
see how to memorize the formulas.
yeah, how do we focus on
trouble.
some? Yeah, we found some weakness. Okay, okay. We can focus on some weakness. Yeah, we were just for example, the I think they always ask question about the wave and the optics, right?
Yes.
Otherwise, some question are yeah, some question are very strange. Few, just a few, not many. It's more compared with the ATAR, it's more flexible. They were the way they ask is different from the text from the question you encounter in the ATAR.
Much difference. You couldn't imagine how much
Wow, well, it's quite different. It's quite different. Yeah.
ATAR question is so like
Standardized, right?
so shallow.
Okay.
It's like they ask the surface.
Yeah. Let's go forward.
19, question 19.
Okay, nearly finished. I'll have done this atom. Yeah, or another is the optics, how to say quantum Bohr model.
Yeah.
I've done this. We have spent more time on this subject. This one, which that's one. We have done that. And the last question. Oh, this is a strange question. Let's have a look. So they have the DNA. Oh, DNA. So basically, there's these devices used to electronically to delay the signal. Time delay. The purpose is to adjust the delay of the electrical signal through the delay to a delay line by switch different amount of the delay into the signal. Oh, I see. So you can see this. If you just imagine that that distance traveled can be varied by switch of each switch. Can you see that?
Yeah.
And because another thing, essentially, we have keep this the electrical connection connected. Therefore, you have at least the minimum distance. The minimum delay is when the switch is down. Can you see?
Yeah.
Otherwise, there's no signal. So either the switch will switch down, which is the minimum, which is a small L, right? And or switch up that there's capital L here, the capital L could be different. So by adding up different delay, the total delay time will be changed, will be affected. You agree? So obviously there's a maximum and a minimum. I saw this. Can you see this? There's a maximum and minimum notation here. The delay line should use the minimum amount of switches. So they are talking about minimum number of switches, which means this is how many switches they use, right? So this is reflected by this subscript of L. Can you see? Let's just annotate that. Can you read the question?
Yeah.
What's I looking for? The delay line should be make the minimum delay and the maximum delay satisfy this condition. We refer delta L as the delay range.
What's delay range?
Oh, that is how can they change the range? What range they can do this delay? Because they are confined by the maximum and minimum switches.
Okay.
So the more switch you use, the longer delay you can make. But they have minimum and maximum. I think that is why that's the question. Yeah, again, this is not very this is not a standard physics question. So you have to learn how to count basically. Can you read there another description? So basically, if you just use the function here, so this I just trying to digest their question. So the delay have certain range, right? So this is if this is delay L total delay, this is a maximum. So this is a maximum. This is a minimum. And that is called the delta L. I use this graph to illustrate the condition given, all right? Can you see that?
Mm-hmm.
Okay, let's read the next one. That is condition. The delay should adjustable is in the increment of delta L, so that the line can achieve an evenly spaced set of delay between this one. So they argue that this there's a constraint that you cannot change that delay too fast, right? So I just draw this probably the category. So if you change, if you want to change every time you use different set of the different configuration of switch, meaning other is on, other is off. Oh, sorry, other is there are two mode here. Can you see this? Can we see this called 0 mode? This is 1. Okay, 0, 1. So by using different proportion of the switch at different mode, then you can achieve that change. But they also argue that that change must be smooth. Can you see? Okay, so there are some constraints. You cannot do this change, all right?
Okay.
So that is what my understanding. So basically, you have to satisfy this step. It's denoted by this small delta L. Can you see?
Yeah.
Any other constraint? It's non-story, isn't it? For all segments in the line, you have to determine a common small delay L, which is achieved when the switch is in a lower position. So what does that mean?
It's a 0 pi.
So this small L is a minimum. Can you see?
Yeah.
When they go to 0 mode, the delay is a minimum. Yes, understand. When we have determined small delay which active when the switch is a lower position. Yes. Now, you further have to determine the larger individual delay. Under this condition, for each segment which is active when the switch is in the upper position. Yes, that's the upper position is what we call this mode called upper. Okay.
Yeah.
Yeah, I'm very tired. You have really folks concentrate to follow their description. So so many conditions. So what they're trying to ask is that is a multiple choice question. For a line with n segment to satisfy the demand on the minimum number of switches, minimum delay, delay range, and delay resolution. First of all, find a value of L in terms of the minimum L and N. How can we do that? So because the L will determine, L is this I'm looking for the function, right? So every time you can at least add the L, do you agree? That's the minimum. If you go to the but hang on, does that mean this in this diagram? Can you does that mean this is resolution delta L? Probably not.
Sorry.
What is the constraint for the L? Because you say every time you edit at least you can edit the L, do you agree? Can we enlarge that one? However, I think this L, this increment is still larger than this constraint, the resolution. Otherwise there's no point to use a different mode. You agree? So my response to this first question is that first of all, this one, so this increment due to the added the L delay, small L delay, is smaller than this delta L. So in other words, we can argue that we have the, what does this N represent? This is N.
Segment.
Oh yeah, this is N. Can we just say NL equal to delta L? Can we build this equation first?
What's a segment? Is this a segment?
Segment is how many? Yeah,
this?
Yeah, that's right. One segment. Yeah. So basically, this is my concern. Can you see? There is a because small L delay compared with my argument is that L itself delay should be smaller than the constraint, the resolution. In other words, we have considered what is a number, because this number also represent how many segment. You can call the segment or unit. Do you agree? So this switch made by different unit. This is unit N, this is unit 1, unit 2, and so on. Do you agree? This is first equation we can build, because they are looking for the this is not directly go to this. Second, we have to consider that what is the relation between this the maximum, the total delay, right? The maximum delay, minimum delay. In this case, we can build a second equation. The minimum delay, what is minimum delay? Is when all the units equal to L. You agree? So I can argue that minimum delay is equal to N multiplied L. Do you agree?
Yes, small L.
Small L, sorry, small L. Okay, you can try. If you.
No, I'm trying to understand the question. I'm still like blurry.
Well, I mean, yeah, we have, yeah. So
I think the increment is constant.
Well, in that case, hang on. This is my, so that's my. Maybe this is not quite right. I think this is exactly what I'm looking for. Do you agree?
Yes, I can understand that one.
Yep. Okay. How about, can we move to B now?
And the delays of each segment.
In terms of this, the resolution, it's called the delta. It's called delta.
What's Li?
Li at any, Li is any, so that you have found the general formula for Li. I is the arbitrary number between 1 and m and n.
Okay. So this one is the increment.
Yeah.
It is not constant.
Well, you have to read. Yeah, I also not quite understand the why they introduce this delta L. Can we read again? The delay should be adjustable in increment of the delta L. That is the smallest total delay. Do you agree? That is smallest total delay. How do we interpret this relation? Find the delays. Delays means many delay of each segment. Li in terms of
the delay. By delay, do they mean the cumulative one or just the individual one?
Oh, they just, for example, if you just consider delay, this is in time now. That not in the previous question, they're dealing with the past. Now they are talking about the time. So basically, if that is the original time taken, right? And they were this time they were added one. Can they added the time here? Can you see the past is increased? Yeah. This is a space, but you can imagine that this is just the time is delayed. It's a time delay.
Yeah, but so, by adding the time delays, they put the switch up, right?
I think you when added all the delay together, can we go so the maximum the total delay? They didn't say what is the formula for the total delay in this case? What is the total delay? Total delay will be the sigma degree of individual delay.
Yeah.
And does that mean individual delay? I think.
Li plus L.
Sorry, you can write down anything.
Plus L.
Can you write it down?
Yeah.
So that is the minimum, right? Plus L, okay. Oh, there are also another two plus 2L, can you see? Plus 2L.
Why?
Oh, plus L, just one L,
plus
yeah.
L,
Plus
yeah.
One, just one L, yeah, okay. Yeah. The delay of each segment in terms of the, no, I think I cannot focus on this question. Can we look at the C? Can we work out the C? Find the minimum necessary N. So probably have used calculus now. Find the minimum necessary N in terms of delta L and the small delta L. Minimum necessary N to achieve that. Well, I think there are two objectives. One is they want to achieve the capital delta L. That is between the minimum and the maximum, right? The delta L. But on the other hand, they have also constraint. This tape that's called the small delta L must be not too small. Do you agree? The minimum necessary N to the number to the term of delta A in term delta L and delta small delta L. Wow. Then we have to recall this question. I think that is what was my first question and first equation. You see. So this is your question. This is your equation, right?
That's just for individual units. That's not the total.
That's not the total, yes.
Yeah.
And well, in that case, I think this reminded me of the pinhole camera. Do you remember?
No.
On the one hand, you have to increase something, but on the other hand, you have to consider another variable. So they are looking for the minimum N. Can you see? So can we call this minimum n, right? Can we just imagine this minimum n here? So basically they have something which depend on both of them, can you see? So in terms of the maximum delta x, we're trying to use a graphical method. If so how can we know there's a minimum n here? Can we just work out minimum delay? Can we this is the first equation? Can you see?
Yeah.
The minimum will equal to that. But that's linear. That's a linear equation, isn't it? If that is L, that is a proportional to n. Can we use this one? Every time it's just added L. Can you see? That is how many. That is how to work out the minimum delay. But the maximum delay, yeah, I think I can try. I can figure out what they are doing now. For the maximum delay, and we don't need that many n. Sorry. So every time we are allowed to edit something, can you see? Can we use different color? So when we just use the red color. So to achieve maximum rate, with this constraint here, can you see? So there's just emphasize there's constraint. Can you see? The constraint is that each of these switch or the total difference. The total difference, can you see this difference? The total difference should be less than this delta. This is called a resolution, isn't it?
Mm-hmm.
How can we connect this? So this is it just read this. The delay should be adjustable in increment of that. Increment of that. Does that mean, does that increment vary over every step or not? Does that increment vary? 1, 2, 3. Can you follow me? This each increment is adjustable increment so that the line can achieve an evenly spaced set of delay between this one.
When they say evenly spaced, does that mean it's a constant?
I think they're trying to make this evenly, so they don't want to jump too hard, too apart. Can you see? This is just one configuration, and but some other configuration could be like this. Can you see? Other configuration could be like this. These we choose this one. The other configuration could be like this one. Can you see? Can you follow me? The yellow colored, right?
Mm-hmm.
But I think what they're trying to avoid is that this is too big. Can you see? This change is too big. That's called a resolution. If my understanding is correct.
I can barely understand it.
Yes, very, very different from the the minimum n in terms of delta L. Doesn't matter, we will stop here. Give me some time. I will just try to work out the relation between these two. Can you see? What is the delta L? Can you see? Because at this stage, I cannot work out what they mean, that this small delta L.
Yeah, I don't get it. Is it a constant or a variable?
It could be, yeah, it is resolution. No, it's just it's a maximum delay. I think that represents the maximum delay for each unit. if my understanding is correct, it's a maximum delay for each unit, for each segment. Does that make sense?
Yeah.
In other words, this should be avoid. Can you see? This should be avoid because that increment is too large. Does that make sense?
Yes.
If this is maximum, if you think that for a while, if this makes for each, they call it a segment or unit segment, then in other words, we have to make sure that the total delay, can we just find, oh, these are sequences, isn't it? Is it sequences? This is what is the formula for that? It's called arithmetical sequences. Do you agree?
Yeah, but increments is different.
Yeah, the decrement is, in this case, is difference. The increment must be
smaller or equal to delta L.
Yes, but on the other hand, they don't have to follow the arithmetical sequences, right? For example, if the total delay can just increase like this. Can you see that? This is what is trying to ask. So if you do that one, that is smooth. So they were trying to avoid this one. You understand?
Yeah.
Okay, in that case, we just work out this each step. Can you see? Can we see this is because this is that L? Is that Li the constant or not? Is this constant or not? What do you understand?
I think I is a term less than n, less or equal to n.
So each segment, the L is different, right?
The integer is different.
No. I'm talking about this one, L sub I.
Yeah.
So does that mean that is constant or not? It
is not a constant. It's just equals to ln.
Ln.
So I is an integer. And
I is the integer, but L is that is a constant?
It's not a constant. It's different for each segment.
Oh wow, that one there's no formula for this. We have found the sigma. Can you see? Do you mean this formula must be worked out? For example, for the first one, the question is how can we find this one? How can we find, because it's changed every segment, they change.
Yeah, and the switching on and off are not in order. See?
Not in order.
Yeah.
Okay, that's right. That's why when you got the sum, doesn't matter. So that's okay. If A plus B is also equal to B plus A, do you agree? Doesn't matter. The order doesn't matter because they just accumulate that delay. Do you agree?
Yeah.
So each time they can use you can use a larger delay. But if that is not as a constant, then it's difficult. If that is a constant, we probably can solve this puzzle. Is that Li? Li, if Li is different.
I mean, you can say that Li
oh,
is...
hang on. You got his answer. You got his answer. Is this what is what you're writing?
That's for individual. That's not the sum.
It's okay. That is okay. Yeah. Because that is different notation here, right? So basically, I prefer to use your notation here, and they just have a cap. Do you agree? That step must be smaller than this delta L. Find the minimum necessary n in terms of delta L.
Or I should say this.
Well, I think we don't have spent more time on this question now, all right? But
So
we can revisit this one by just think about how do we accumulate each delay, okay? And we can simply work out the minimum delay. Oh, how about the maximum delay? Do we have? Can we use maximum delay? Can we work out a formula for maximum delay?
Yeah.
Maximum delay is that each time they have reached maximum reaching equal to this. Oh, I got it. I got it. The maximum is n delta. Yeah, n delta. No, that's minimum. Maximum is delta. That's all. Because you cannot, each unit cannot go over that one. So each delay at each unit must be smaller than that one. Does that make sense?
Yes.
Okay, I think we solved this problem now. Can we just I can use this area? So my point is that this is two basic equation we can write. So the minimum delay, the accumulated. The accumulated is equal to that's the minimum. That's the n multiplied L, and the maximum. We just write another equation. Is just equal to n when everyone go to this limit. Can you see?
Yeah.
Do you agree? These two equations are useful. And addition, delta L is just different between these two. Can you see?
Yeah.
N equal to, I think delta L is larger. Delta L take L. Do you agree?
Yes.
So N is solved. Are they looking for N? N is solved. But the question is this N is a minimum or not? Yes, that's his question. Can you see?
Yeah.
As simple as that, right?
Oh.
Is do you agree?
Minimum. Yeah, the minimum.
That the question is, if there's n is minimum, how do we achieve the minimum?
What does it mean necessary to achieve what?
Well, you have to you cannot have zero, right? Therefore this minimum number must be larger than zero, larger than one rather. Okay, you must more than one unit to do this delay experiment. I think we were stopped here. This is progress. Do you agree?
Yeah.
If you want to go further to justify this, how do we find the minimum necessary? Because this n, we will just ask you one more question. Is that n is necessary? Can you say, do we have to go that? Do we have to ask? Do we have to make every segment have that delay, namely delta L? Do we have to?
I don't know. Like if they ask you what's necessary, they must have like asking us to achieve something.
Well, I think we'll stop this formula here. All right.
Yeah,
pretty,
I think that's
pretty useful now. I think.
Yeah.
Save that one. I will go next one. Okay, let's go back. I think that's all, right? Oh, this algebra, this geometry. Oh, one more question. Can we try this one? This geometry, I think. What they're looking for. Conic. Yes, always use this. Yes, very typical question. They use conic. All right, can you try? I think this is just geometry, I think. So make some area for cross section below. Yes. Maximum volume. Depth. Find the expression for the depth h to which you have filled the cup so that it contains a volume of liquid equal to half. Ah, you have forecast the formula for the at a small h is halved. Okay, that's right. Good idea.
Should only depend on the dimensions of the cup.
So what is the, so that's right. This is volume. So you have two volumes. So you have make sure you have set up equations that these two volume are just half. Can you see? So this is a can you is a volume 2. So original volume 1 or original is the same formula, but they use this can we use the D? They call the D half D, right? Pi r
D over
half,
2.
half D. This thing is very simple for this is very simple equation. So another condition, the difference is that the V1 is half, can you see? Equal to 2 of V2, isn't it? That is 3 equation. Do you agree? So no numbers, just a formula, right? Expression for h. So that's why I use analytical formula, because sometimes this examiner prefer student to use analytical formula, not just okay. What is your small d? The diameter here at that level, water level? All right, you can use your notation, Dermot. Where is the small h? Your formula, where is your small h?
In here.
Oh, yes, okay.
Yeah. 12 times 8 times 2.
Oh, I think it's very simple. It's just similar triangle, right? It uses a similar triangle. It's a similar
And I
triangle.
want to equal these two together.
Uh-huh.
So that 1, 3 pi d squared over 4 h equals.
Yes, you just simplify that and
Only depend on the dimensions of the cup. So I need to eliminate the d, the small d.
yeah, that's right. Well, so you have used this triangle. This is the same.
Yeah.
I think this is similar triangle. Two similar triangle here. So this is small. Is this small d, right?
Yes.
This small d here, and a large d. So this just you have used the ratio. Okay.
I need
So these two ratio will be the same. So basically d, or I can't write, d over h is equal to capital D over h. Do you agree?
Yeah.
It's rather simple. This question is for middle school student.
So d equals dh over h.
Yeah.
So you just sub it in and then
that's right. Yeah. So that is a question for you. All right. Let's stop here today. Save this part.
Thank you.
Okay. See you Saturday. Okay.
Thank you. See ya.
Goodbye.
Bye-bye.